All right, then. We should be up, and it is time for Scala Day 3. So, not quite here yet. I suppose I'll get there, but we currently are doing domain modeling and functional programming modeling. So I know a little bit about FP. Hmm. It seems like this is a little bit messed up. Test. Okay, so this is delayed. Properties. Maybe if I did this, would that help? Would this? Okay. It seems to be fine either way, actually. Okay. All right. So Scala, reading a bit about case classes, etc. This is fairly familiar. A little bit of extra syntax for what you see in Rust. But yeah, it's very nice. You have this pattern matching you can use. I could say, um, I don't know. I could always build like a JSON parser with this. So like, if I were to do that, you would have something like enum value. You would have your case class, null. No, this would just be a case. You would have case class number, which you'd probably make into a double, right? Etc. Right? And then you could have your case class string, which would be have a string. A little awkward because you still have to define stuff like this. You can't just do this, which is a bit unfortunate. But you'd have something like this, case class. What else can you have in JSON? You could have another object, right? So you could have, which would be another thing. Then you would have your enum object, which would have your entries, right? So list of entries where entry is a um, entry has a key and a value. Something like this. This is how you generally model a right. So this should be a case class as well. Something like this is about what you would expect for a JSON parser. If I'm not forgetting anything, also you need a Boolean, which would have yeah, right. So you could say, well, say I was to try and do the following. Um, Name, person, age, 15, male, true, or something like that, right? You would model that as object list. You have your entry, which goes from name to, and in fact, you could be smarter about this and build like an operator so that you could just write name to something, right? But I'm not gonna worry about that. Value dot string if I'm not mistaken. Is this an issue? Value. Mm-hmm. Hmm. Construct enum variant Scala. Well, then how do you construct this? I want case class, please. All right, there. We want algebraic data types. Which is um hmm. This is strange, because shouldn't this work if I were to just do, hey, say val x equals value dot string. Yeah, well that it doesn't recognize that either. So it must be nested, but when I nest it, that doesn't really work either. Hmm. But like this is what they show, right? Oh, you don't write case? Oh, no wonder. Illegal reference to class object from string 2 is a class in object value. Right, so this is going to be kind of an issue. You want to avoid, um, right, but this is just bad practice. Well, either way, that's how I'd kind of do it. You would have something like this, then you'd have something like this. And the nice thing about this is now these would all be um, this would kind of be your objects, right? And these would all have, all the entries would have the same type, just storing different data because pattern matching would be able to get rid of them. And that would be the only thing you could do. So you could go and say, well, person dot entries dot 0 how do you even get something at what even are these operators, man? Like, what is this? My goodness. Am I being dumb? Head? Really? Okay, so maybe I want to use a sequence here, not a list. Hmm. Interesting. I mean, sure. I mean, I can respect it. Replace with dot head, no thanks. But you could also do this, right? Dot find. Why is this gonna give me a boolean? Shouldn't. Oh, yeah, it returns option entry, right? Yeah, so you could do this. You could also make it like a method on object. So you could give it this property called, I don't know, at, or better yet, apply, right? But I don't know how to use that yet. Ooh. Okay. All right. So I don't know how to use that yet. I'm just gonna say entry, right? So def entry, which takes an entry name, right? So name string, and it's gonna give you back an entry, right? And what it's gonna give you specifically is this thing's entries dot find the one where the entry name equals that name, right? And then you would key, right? So this should be key. And then this will give you an option entry, right? But you want to get an entry, so you do get. And that's all. Okay. This is unwrap. So if I do, by the way, none.get, that crashes me, right? At runtime. Okay. That's what I would expect. That's just unwrap in Rust, basically. This then is here. You have this. Why doesn't... Right. But in this case, yeah, I agree. I don't really like the white space syntax, but in this case, definitely I'm going to leave it this way. Something like this, you would have person.entry name dot value, right? So that would be kind of how you do it. Or better yet, you would want to actually return the value. So this function should return right? Ooh. And then you want to have a flat map? Map. Just a map here to its value. And yeah, this should be an option value. Okay, I don't know why it decided to format like this, but whatever. Bit of functional programming, good for the soul. You would just say dot get name. And there you should be able to do person, right? So then you would also want something like this, right? So you would have your name, which would just be known to be a value, right? Or even an option value. So this is where the power of pattern matching, you could match it to say, well, if it's some string name, well then print, oh cool, so like found name. Name. This should be this. That is also not good enough. It has to be this. Honestly, I can respect it. I have no problem with that. Am I sure I need these unders? Yeah, I kind of do. I'm gonna call these like J string or something. J object, J object. No. Better yet, this should be like this. This should be considered J object. This should be considered J entry. Okay, all good. And then here you have your J. This just seems normal. You would have to turn it back here to string as well. Right. Well, that's where you have your issue. Okay. I'm just going to revert that. That didn't really work out in my favor. Yeah, it was fine how it was. And then otherwise, they will get mad at me for not being completely done here. Is that what this other thing's about? Right, not exhaustive. Nothing. Great. Well, that doesn't have to be an S ring, but cool. Cool. So really some nice nested pattern matching. That's sort of the good stuff, right? That definitely is the nice good stuff. Yeah, so this I can absolutely respect. This is good. Better yet, you just do, yeah. But either way, right? This is very nice, very satisfying, very cool use of maps. So now I'm gonna get into some better programming habits for sure. All right, as we continue, you have stuff. Mm-hmm. So it's saying the answer is quite simple. Cool pattern matching here, right? I wonder, can you do this kind of deep nested pattern matching? Well, only if name is the same type, right? So you have to be careful. Um, but if you have, say, none or name value dot, right, cool. So this would be a nice use of it. And then otherwise you'd print, well, we found name, but it's in the wrong format, right? Or better yet, you can do some nice stuff here. Be smart about it and just say val status equals name match. Print the status. This is very cool. I do very much like this. Nice use of pattern matching. There's nested. There's etc. etc. Right? And you can have, so this is where a flat map would actually be useful, right? So I can already see where you'd want to use flat map. When you have this sort of nested object thing, right? You have, say you have something that's like this, right? So you would have an entry, which is a friend, and then you have a value object, oops, containing another object, right? So with no properties, let's just say, or better yet, with just a name, so we only know their name. Entry name value dot string person2. Okay, so this is a bit of a mouthful, but trust, right? So with that said, you could try and use flat map here to go val friend equals person dot get friend dot flat map person dot get name. All right. Value is not a member. All right. So let's see then. What is F here? Once you get friend, this should be an object. Ah, of course. Right. So it only knows that you have a value. You would want to do, is there an as as keyword, nope, not Kotlin. Oh well, I know about this, but wouldn't it crash otherwise? Okay, well not. You know what? I will just leave this because I don't think that's what I want. F match. Case test. Uh, please work. Nope. Okay, well, it's still not good enough. So I thought here now F would have object. It does. Value object dot. Is not a member of value dot object, but isn't it? Oh, of course. Right, of course. So I would want to do this. That should work. All right, so a bit of a uh, bit of a convoluted use of flat map. But now this should be completely flattened and mapped and all that cool stuff. Um, okay. It's a little awkward, but I guess it works. I guess so. I mean, there must be a shorthand for something like this where you're transforming it if it meets the case, but I don't know, it's not awful. Just a bit awkward is all. Okay, I have a pretty good understanding of pattern matching. So pattern matching, define your function and companion objects, use a modular programming style, use a functional objects approach, define the functionality in extension methods. That works too. All this stuff. First approach is to define the behavior in a companion. Okay, so this is really just about where to put your functions. I already do stuff like this. This is already how I kind of put my things. Okay, let's go to modules, I guess. This looks kind of boring. How do you do deep copy Scala? I'm good. I'll check this later. It's kind of boring. Let's move on to methods. Okay, defining methods. So Scala methods have many features. Brilliant. Including these. Okay, you have generic type parameters, rah rah. Default parameter values, multiple. So this is currying. Never heard of this. This is just name parameters. All right, let's see. Simple method is this. This is disgusting. I'm not doing this. I'm gonna stick to this. Thank you very much. Any one-liners, I'll do this. Not one-liners, I'll do this. Thanks a lot. Right? Because this end syntax is disgusting. I hate it so much. Blah blah. Only recommended for long methods. The issue with this is that it's way too subjective. Like, what do you mean a long method? Right? It's such a pain to write that I wouldn't put it on anything if I could avoid it. So it's just going to end up with programmers being lazy. Okay, add. Right, so that's all good then. You have main def main. Uh, oops. That's not what I'm trying to do at all. Okay, let me just put this here. Right. So it really wants you to put these things. Good to know. Good to know. Size, contains, map, etc., etc. Is map even lazy? Lazy map, Scala. You are looking for a cache? Oh no. I mean, there must be a way. If Kotlin has it, surely this very functional language will have it. I mean, surely. All right. With that said, let's move on. Blah, blah. Start the method body on the second line, etc. Okay, wonderful. No need to use return. Okay, this I know very well. Can I use... Okay, this is probably easy enough. A real-world multi-line method converts throwable input parameter into a well-formatted string. Okay. First line creates it, then it prints a stack trace with some new object, etc. Method parameters can have default values. Yep, all good. Here are a few key points about these examples. First example, blah, blah, blah. All right, all good. Named parameters, this I know about. Kotlin thingy. Suggestion about methods that take no parameters. Okay, arity. If it performs side effects, declare it with empty parentheses. If it does not perform side, so these is getters. Leave the parentheses off. So this I actually don't hate, right? You do this, you do this, you do that, blah, blah, blah. Then an arity 0 method performs side effects. I absolutely agree with this. This is very smart. This is very good. It's very nice to be able to see something like that. When you have like a getter, for example, it makes it pretty convenient to go do something like that. Right. If A is 0 or A is any, some brilliant any work going on here. This could also be a thing. First of all, what is like? Write better code. Come on. And A is not false. Okay, if A is not 0 or A is not this. Alright, easy. This is all you'd need, right? Or you could make it even better. So you could do a match. Nope. Case 0 or this or false. Then return, well, it's not truthy, right? But otherwise, it is absolutely truthy. So there you have expression. It does nothing in statement position. Oh, so compiler doesn't like me much for that, but there we go. Right, that's also a little bit more readable. But yeah, I mean, you can't beat the basics. I mean, come on. A is not 0 and A is not this and A is not false, then it's truthy. Better yet, make an is falsy method and define it as define is falsy as the opposite of is. There's none of that? Okay, bit annoying. Falsy A, and then this would be here. Here's what I don't like about, I mean, what is this, man? Yeah, so I don't know, something like this. But yeah, this is all just dumb stuff. So this is actually, yeah. I actually do wonder now, when you do something like this, with the match statement, right? Where's my match statement? Alright. Ugh. Match. Saying 0 or this or false, then yeah, it's false. Like this, right? But with that said, what happens if you call it with 0, 0.0, so the double value? Could not find or, okay. Why is it called hello? That's so dumb. Okay, so this 0 matches 0, 0.0. Good for them, I guess. Okay, then let's continue and um oh cool, this is literally what I did. So there you have it. I mean, matchable trait, I'll get there eventually, right? Hold on. This then illegal start of top level definition, rah rah rah, right? So then here is my issue with it. Can you do this? Okay, thank goodness. Whew, I was gonna say. Also, this is cursed. Can we not do that, please? Can we do it like this? Alright, great. This way makes it easier to just add stuff. So you could have like, I don't know, name string, right? And then you say, my name. No. What am I thinking? I don't know. Dog name, right? Oof, I'm. Right, to something like that. Fairly easy. Methods can be marked as private. So do you have to override them? So here's where you get interesting stuff. How does overriding work? Right, when I have something like this, this has obviously an issue with this, right? Because you can't override nothing. Can you do this? You can. Yeah, that kind of makes sense. I think in Java that would crash you, but anyway, can you just override stuff without saying override? No. Okay. Well, that's good. That is good. If you say There's also open class though. So what's the point of an open class? If you can already nope. Neither abstract nor open. Okay, so it can't be uh extended outside of that file. I see. Yeah, well either way I'll try to stick to competition instead of inheritance, and then we should be good. Alrighty. If you want to make a method private to the current class and also allow subclasses to call it or override it, make it protected. Okay, now this already all good. Objects can contain methods, all good. Ugh, I hate this syntax so much. Look, this was fine before. I mean, there was nothing wrong with this. Anyway. Wow, that's just a bit disappointing. I mean, what were they thinking? You have extension methods, which are silly, but yeah, extension methods are great. Okay, I don't know what an implicit class is. Okay, interesting. Well, this is definitely not something I'd want to use. This looks pretty good. With that said, I don't know what implicit classes are yet. I guess eventually we will get there. Okay, so that's just basic introduction. So when you want like a basic getter, right? Uh, you would have basic getter is going to look something like it only makes sense in the scope of an object. So you have a class cat, right? And it has an age, which is an integer. And let's make that a private variable, age, which is an integer, right? So all good. Now, let's say we can have a grow up function. And that just makes age plus equals 1, right? All good. With that said, we should have a function which gets the age and it returns an int. So this is obviously not going to work. Right. So this is how you'd basically do a getter and setter. So what you'd say is val x equals cat with age. Better yet, let's make this classical age, or I mean default value. And then we'll say, okay, well, grow it up, right? And now let's see what its age is, and we can do it in this nice way where you have these kind of hygienic getters and setters, etc. Okay, so that's very nice encapsulation. No more get methods, etc. This is similar enough to what you see in Kotlin. Hmm, this is cool. Ooh, what is this? Um, interesting. I still iffy about some of the syntax here. All right, anyway. Um, I mean, this is actually kind of cool. Um, I feel like this could also be simplified. Hmm. Right. Command line parser from string. Yeah, that's actually kind of good. That's not bad. I don't know how flexible it is with stuff um, like actual command line arguments and flags and stuff, but you'd have to, must be libraries for that. Wouldn't be a bad first project, actually. It would not be at all. With that said, um, okay, well, I'm not reading any of this. Create an object that extends the app class, blah, blah, blah. Okay, brilliant. Mhm. Oh, cool. So use iterable for everything if you can. Okay, all good. I mean, I get this. For x from 1 through 10. Yeah, I still don't know about this. Right. Yeah, I don't know, man. I think I'm gonna keep using curly braces for quite a bit. Okay, I don't really care about this main method stuff. Okay, so these are all your method things. I'll get to it later. Now we have functions. But that will be something to do for another time, because right now I have to go. So maybe next time we will see about functions and good stuff like that.